Hello, welcome to my database presentation. My name is Kendrick McAdams, and I will be showing you my database. So I'm going to start off with my project description. What I did in this project is I created a database for a kindergarten. This database allows the tracking of important things such as the information of student and employees, as well as their absences. It also keeps track of information such as financial, inventory, and class information. This will assist kindergarten through many different ways. First, it helps increase the organization. Paper storage can get kind of unwieldy and really be confusing once there's a lot of records to keep. The good thing about databases, though, is they're much easier to maintain, to add and remove things from. It's just a lot more organized than trying to use a paper file cabinet situation. In addition to this, it's much simpler to store data in a database than in papers. With paper storage, when you have to first make the records and then find the place where they go and then add them, and you kind of got to keep track of them. But the good thing about databases is that once you put it in there, it kind of does the keep track of them for you, and you could easily access them much faster than you could with a paper solution. Finally, it is much more efficient than paper storage. Paper storage can be kind of unwieldy, and like I said, if you have a lot of records, it can start getting pretty big. A lot of file cabinets, you have to go through a lot of sifting through files. It's just a mess. But databases, through SQL and stuff like that, you could easily find what you need much faster than you could with a paper solution. So to talk about my project, first I'm going to give kind of a general description. So this database is made to give a wide variety of information, ranges from information about students, information about employees, to the inventory. It kind of gives like a broad view of the whole kindergarten. It holds different types of information in different tables which corresponds to what type of info it is. For example, if it's information relating to the student like their ID or name, then that's going to be kept in the student table. If it's information about the room, it's going to be kept in the room table. And the benefits of this, it's my database has a pretty simple design. I didn't try to complicate it too much, especially because a place like a kindergarten, they're not going to have really advanced IT services for the most part. So you want to make sure it's pretty simple and easy to understand so that they won't need the IT person to access the database. Consolidated. It's pretty consolidated. I try not to spread things out too much because, like I said, it needs to be pretty accessible for any kindergarten employees that know SQL. Because of this, I had to make sure that I didn't complicate it too much and add too many complicated procedures in it. And finally, my database is easy to understand. I kept it simple. I made sure that it was the table name, the attribute name, they were all pretty descriptive of what it stores. So it's pretty easy to understand. So now I'm going to go through my tables. First, I have the student table, which holds student information such as student ID, student name, the student balance. So pretty important things about the student. Student absence also holds their absences. So if they got an absence, then it'll be stored in student absence instead of student. Guardian also holds the student's guardian's information. So if the parent's name, the relation to the student, their phone number, it'll store that so that if the kindergarten needs to contact a parent, then they're going to be able to. Class contains the student's classes information, such as what classes they're in, the class ID, and the score that they're making in there. Room contains information about each room, like room ID or the type of room, such as cafeteria or classroom. Inventory, it contains inventory information about each room. It's pretty descriptive about itself. So it contains the number of desks in a room, the number of computers in a computer lab, important things like that. Employee, it contains employee information. So their salary, their name, their date of hiring, important things like that. And finally, employee absence contains information of employee absences. As you can see here to the right is my ER diagram. There is, as you can see, you got the student table, the student absence table, class table, room table, inventory table, employee absence table, employee and guardian table. These are all different tables that are store information about each of these table names. And I'm not going to go through all of them because there's a good amount and it might take a little bit, but if you would like to, you could just pause the video and take a look at it. So now I'm going to my SQL queries. So here's my first query, which I wanted to do a select with ordering. So as you can see, I just asked it to select all the attributes from student and order them by their last name. So as you can see here, here's their last name. It's Bauer, Bentley, Brady, Cox, Crossley, Giles. It's in alphabetical order by their last name, which shows that this worked correctly. And the second one, we were supposed to make a medium level query. So what I did is I wanted to show information about the teaching employees, which includes how their salary is compared to the average salary of the kindergarten. And to kind of to concentrate to limit what records are showed, I made sure it only showed teachers that are above than 5,000 less than the average salary. So as you can see over here, we've got I selected the employee ID, last name, employee type, salary, as well as the salary divided by the average salary from employee, which I named the column percentage of average. And I made sure it only specified where the salary is above 5,000 less than the average salary, and the employee type was teacher. As you can see over here, it shows the teachers that make above the 5,000 less than the average, and it shows their percentage of the average. So it shows that it worked correctly. Here's my third query. This is a composite query, which shows information about specific classes, which includes the average score meet in each class. And it also limits the classes to the ones that end before 11:20 or the ones that start before 1 p.m. Start after, sorry. So as you can see over here, I found the class ID, room ID, the average score, as well as the start time and end time of classes where the end time was either before 11:20 or after 1 o'clock. And I grouped it by class ID and ordered it by start time. So as you can see over here, I've got the class IDs, the room IDs, and the average score that all the students are making in it, as well as the start time and end time to ensure that these were correct. And here's the fourth query. This is where I made a subquery, where I found the ID, the first name, last name, address, city, state, and zip code from students who had a absence. As you can see, I made sure I specified where where a record for the student absence exists. It would show this information from the student table. And to do this, I used a subquery that found where students who also had a record in the student absence table. And the fifth query was an inner join. So what I did is I wanted to show rooms that have inventory items as well as the items that they have inside. So as you can see here, I selected a few attributes from these, and then I joined the room table and the inventory table and order it by room ID to show all the items that are shown in each classroom. And if you look at the information right now, it doesn't really make much sense because a classroom wouldn't have just 15 desks, 2 chalkboards, and 20 cubbies. But the thing is, since the data you wanted us to have in the project was only 20 lines, so I just tried to spread the items across different rooms to make it look more realistic. So that's why you definitely need more things than that, but it's not really the scope of this presentation. So now here's a right outer join. Well, what I wanted to do here was show information about employees who have been absent. And since I used the right outer join, I was able to filter out employees who had not had absences. So as you can see here, I selected information about the employees from the employee table as well as the employee absence table. And since I used the right outer join, like I said, I was able to exclude employees who had not been absent, which is, if you're just trying to find the employees who are absent, this is a very useful tool. Finally, creating a view. So in this view, I created a view called Full Inventory View, where I collected information such as the room ID, the type of room, the item ID, item name, and quantity from the rooms. And to do this, I had to join it with the inventory table. And this would pretty much show all the inventory we currently have in the school and order it by the room, which is kind of what I did earlier, but I was creating a view for it. So if somebody wanted to see it, they could easily use this view. And here I executed the view. As you can see, I selected all from full inventory view, and here it is. You can see the inventory of all the items that I have in the database, and it's much less programming than if this was a common query you would make. It just makes sense to put it as a view, so it's much easier to program. And here's my 8th query, which is a union query. So in this, I'll first use the full inventory view that I created in the last one. But also, I use the one that's called inventory above 12, which it's pretty much as it sounds. If it stores the inventory of rooms that have items above 12 items. So as you can see here, I use the union to join these two things from the full inventory view to the inventory above 12, which shows the information for rooms that have above 12 items. Here is my 9th query. It's a custom stored function. This is a function which I stored inside the table, where it checks the student's balance and sends a message to it depending on the value. So as you can see here, I pretty much said check the student balance. If the student balance is above 0, less than 0, then set the balance level attribute to negative. If it is 0, or if it's between 0 and, it's not shown here, but it's 25. If it's between 0 and 25, then set the balance level to low. If it is above 25, then set the balance level to good. And that's pretty much the extent of this function. And I will show you how it worked in the next slide. So as you can see here, I have I made it show the student ID, so we know which student it is, as well as the balance check function. And as you can see, for the first student, it says low, which means that they have between a 0 and 25 balance. For 200001, it shows negative, which means that it is they had lower than 0 balance. But the fourth one, the one that ends with a 3, is good, which means that they have above 25. So this is like kind of a quick way that the school can see who they need to contact about increasing their balance. Here's my 10th query, which is a custom stored procedure. This procedure, it will select the information from students with unexcused absences, which the unexcused absences for this database is ones that are either null because it's an optional attribute, or one that has personal reasons as the reason. So as you can see here, I made the procedure select all from student absence, where absence reason is null or absence reason equals personal reasons. And so this is a pretty simple procedure, but it is very important for a kindergarten. They could easily just run this to find out who has unexcused absences and just, email the guardian or whatever just to make sure everything is good. And here's my procedure in action. As you can see, I called it and it showed the student IDs as well as the student absence IDs that are connected to these, their absence date and their absence reason. So doing this, it allows the school to quickly see everybody who's absent. And here's the extra SQL queries. Since I was doing an honors contract, which means I had to do a little bit extra for the class. This is the form that the extra work came in, which is a little bit of extra work for the project. Here's my 11th SQL query, which uses the except operator. Now, since my SQL Workbench did not support this function, I had to go and make a Microsoft SQL Server Management Studio thing, and I had to recreate my database in there. So that's why it's different, but it's pretty much the same database. It just looks a little different because I used a different program. So on this, I had to create two different views to demonstrate this operator. All students shows all students in the database, and absent students, as it sounds, it shows all the absent students. So using the except operator, I made it so it would show all students and then except the ones that were absent. So this would be useful in the awards at the end of the year for people who have all no absences or something like that. So this can be a useful function for that. Here's my 12th SQL query, which is the intersect operator. So this query will show the rooms in which both have a class and employee assigned to them. So as you can see, it'll first select the room ID from rooms where the room ID has a class connected to it. And then it'll intersect this with a query that selects the room where the room ID has an employee connected to it as well. So this kind of shows the classes that are currently in use for a class, or something like a cafeteria, such as something like that. Just something that has an employee assigned to it, so it can be used to find empty rooms or things like that. But as you can see in the bottom, it shows all the rooms that currently have a teacher and a class and an employee assigned to it, which right now is only these 6 rooms, but if it was a full-fledged database where the kindergarten actually entered all the data they had, it would be much more full than this. And one more thing I did is an SQL query. It's my 13th SQL query is an SQL trigger. So the trigger is something it'll check the database or the table each time a certain thing is triggered. So for what I did in this is I made it trigger before the insert on an employee in the employee table. What I wanted to do to this one is somehow, for some reason, they accidentally put a new employee in with a salary that's under the federal minimum wage. I ensured that it was brought to the federal minimum wage so that that error wouldn't cause any problems. In addition, you could make it so it sends an email also to the whoever's checking for that stuff, whoever's in charge of the finances. But I didn't really have somebody in charge of the finances for this because this wasn't an actual database for an actual kindergarten yet. But as you can see, I said for each anytime that an employee is inserted, you have to check the salary, and then if it's below 15,078, which is a federal minimum wage, you would put it equal to that. And here's where I test it out. So I inserted a new employee in, and as you can see, I made their salary 10,574, which is below the federal minimum wage. And then I went to select the information from the employees. And as you can see down here in Arish Larson, which is the employee I just entered, their salary is now 15,078, even though I initially inputted it as 10,574. So as you can see, this means that the trigger actually worked because it changed their salary. And now I'm going to go over a few of the difficulties of the project. So there was a few project difficulties, but thankfully I was able to work through them. But they taught me a lot about databases. So first, I had difficulty planning the database. This was like the largest scale database I'd ever made. So there was a lot of different things I had to think about, such as what should be collected in every table, what tables I should have, how I should make it, how I should plan it so that it wasn't too confusing for the users. There's a lot of different mechanisms that I had to think about when I was creating it, which it was kind of hard to figure out, but once I did, I was able to make it. In addition, I had to make a large ER diagram, as there's a lot of information that a kindergarten needs to function. The ER diagram that I made ended up being a little big, which it looks a little crammed because it was kind of hard to stuff it into one screenshot, but I think it's pretty organized with the extent of it, and it covers all the bases of a kindergarten and what they need. The second area of difficulty was the creation of the database. As I said, it was the largest database I'd ever created, so there was a lot of table making. I had to make all the information for the table. Had to make all the tables. Had to manually create all the data that I was inputting into the tables, which 20 entities for each table. It doesn't sound like a lot, but once you have a lot of tables like I had, it turns out to a lot of programming. But it worked well because it helped me get used to using SQL. In addition, I had to work through a few errors in the code when creating the database. For example, the apostrophe key when I was typing I first typed it into Google Docs. I typed all the database creation code so that I could rerun it if I needed, if there was an error and I needed to rerun it. But turns out the apostrophes in the my Google Docs is different than the apostrophes that are used in the MySQL workbench, which caused a few problems, especially when I tried putting it in and it wouldn't work. And I was really confused until I figured out that the problem was that the apostrophes were different. So I had to go through and change all the apostrophes, which took a little bit, but I was able to get it done. Finally, I had to do a lot of diagnosis and testing. Since there was a lot of information, a lot of different stuff, this is the biggest scale I've ever done. It meant that I had to test it a lot to ensure that everything was good. I had to diagnose all the problems with it. Took a little bit of looking around in the code, but I finally got it all done, and it made a good database. And finally, the SQL queries. While I understood the queries, I was still comfortable with a few ones, especially some of the more advanced ones like triggers and procedures and functions. Those were a little bit difficult, especially with the kind of weird formatting they require with stuff like delimiters and ends and stuff. But it took using the extensive documentation that was in the book or that was online. I was able to fix some of the queries that I was having problems with and made queries that all worked. So I was able to work through that one, and thankfully it taught me to use resources from the book or the internet in order to help fix problems I had. And thank you for watching. That was everything I had about my database. So I was glad I could make this and show it to you, and I hope you have a great day.